students, welcome to section 4-5, determinants and Cramer's rule. A 2x2 matrix has a second order determinant. A 3x3 matrix has a third order determinant. 2x2 is a square matrix, as is a 3x3. So for the second order, if you see this 2x2 down below, A, B, C, D, the determinant is noted with these kind of absolute value bars around A, B, C, D, simply A times D minus B times C. I will expect that you do this both with and without the calculator on tonight's homework. A third order determinant is a little bit different. Although it is a square matrix by definition, 3x3 of course, the determinant is found by using something called the diagonal rule. Again, I will ask that you do this both with and without a calculator, as you will run into the same situation with a 2x2, although this is a little bit more complicated. This is your 3x3, let's say, to start with. What you're going to do on the diagonal rule is you're going to rewrite the first two columns right next to the 3x3 matrix. And you can see what they've done here. They've drawn lines through those respective diagonals such that what you'll do is you'll take A times E times I, and then you'll take that plus B times F times G plus C times D times H. That entire quantity, put it in parentheses when you're doing it, but subtract then, so minus, and then you'll go in the upward kind of manner with these diagonals. So again, minus G times E times C plus H times F times A plus I times D times B. That will lend then itself to a singular value, just like a second order determinant. A third order determinant will be just a single number. And we'll talk about maybe applications of these in a little bit. The most kind of significant application, though, of using a determinant in any context is the area of a triangle. The area of a triangle having vertices A comma B, C comma D, and E comma F is, well, the determinant of A, which will be a 3x3, where A, the area, is equal to 1/2 times, look at this 3x3, and the determinant setup. So you have AB, the first ordered pair, CD, the second, and EF, the third. Well, notice the third column is simply just 1. You're going to be able to do this using the diagonal rule, or you're going to be able to do this using your calculator. We'll talk about both here. Let's take a look. The example that follows, parts A and B. Part A, evaluate the determinant or each determinant. You've got a 2x2, 6, 3, negative 8, 5. So the math is as easy as 6 times 5. There it is. Minus 3 times negative 8. Notice the parentheses kind of help us justify or more specifically note the numbers in context. When you do the math here, and the answer is not available, but we'll go ahead and do this quickly, I think, in our heads, which wouldn't be too difficult, I argue. 6 times 5, which of course is 30, and then minus 3 times negative 8. Well, 3 times negative 8 is negative 24, but minus negative 24 becomes plus 24. So 30 plus 24, well, that's easy, that's 54. Moving on, so part B, this is a 3x3. All the work, thankfully, is expressed here. So next to your 3x3 matrix, written in, again, determinant form with these kind of absolute value looking bars, you can see here the 3x3, wherein next to it, with those first two columns rewritten, we're able to do the diagonal approach. So 4 times 3 times 6, there it is below, plus 5 times 0 times 2, there it is again below. And then again, negative 2 times 1 times negative 3. Notice they put brackets around these quantities only because you're then going to take that entire value and subtract the upward diagonals in the same basic manner. So 2 times 3 times negative 2, right here. And then negative 3 times 0 times 4, which is right here. And then 6 times 1 times 5 right here. Again, do all of that analysis. You're going to subtract those two quantities, which they've done for you a little bit more in depth. And in full, you can see they made a mistake. The second number is 18, not 16. So the final answer ends up being 78 minus 18, which actually ends up being 60. Okay, I'm going to show you what the graphing calculator analysis entails, so let's take a look. I've already typed things in for you. Second matrix. I've already edited matrix A. I'll show you real quickly what that looks like again. So if you go to edit, matrix A, as this 2 by 2, literally I hit 2, enter, and then kept going with all of those values. Quit the matrix once you've typed it in. You go back into the matrix. Option, well, math first, if you scroll over, but option 1 will be the option we utilize for the determinant. So second matrix, option 1 again. Remember we had said that the answer to this particular matrix determinant was 54, 30 plus 24. So there you have it. I'll do the same thing, second matrix, math, option 1, second matrix, option 2, because we want the 3 by 3 determinant, of course. And if we hit enter, of course, we end up with our answer to be 60. Now, I do want to still take a look at an example, maybe not particularly from, maybe what we saw similar to A and B, but more specifically with regards to, finding for number 4, the area of a triangle. Now, I'm going to use my calculator exclusively on this. I do recommend, though, that you also practice this without a calculator, just to kind of give yourself a perspective as to, how this can be done, on the diagonal method approach. Notice I've already hit second matrix as I was talking here. I'm going to edit matrix C, option 3. And we're going to type in our 3 by 3. Every time you find the area of a triangle using this particular approach, you're going to type it in as a 3 by 3 with the ordered pairs as you see 2, negative 3. The third column will always be 1. So 2, negative 3, 1, 7, 4, 1. And then lastly, negative 5, 5, and then again 1. So we'll go ahead and find the determinant of this, hit the, quit the menu first, but then go back into the matrix and hit the option math, determinant. And then we're going to do second matrix, option number 3, and find the determinant of matrix C. Now remember, this is not the answer technically. 89 will need to be divided by 2 or multiplied by a half technically, which I'll do pretty quickly and easily as such. So I'll multiply by 0.5. The answer ends up being 44.5. So number 4, that's the area of that triangle. One thing to kind of be mindful of is when you're doing these questions, sometimes your determinant will end up being a negative number. If that's the case, and I'll make a notation here maybe later here, but plus or minus a half technically needs to be a part of this formula. I believe that's yet another maybe just editing error that the writers didn't take into account, but it's technically true because your determinant in fact could be a negative number, and if it's negative, having a negative area doesn't make any sense. Negative area, that is. Negative value. So what we do is we put a plus or a minus here, and if in fact the determinant is negative, you multiply it by negative 0.5, giving you a positive area. All right, let's finish up on the back here, Cramer's rule. Now, I'm going to argue that Cramer's rule is one of the methods that you can use to solve systems of equations. So this is a system of equations. If you all recall from chapter 3, we spent quite a bit of time on that before remote learning. Cramer's rule is a method, but it may not necessarily be the best method. I'm going to ask that you, in fact, do your Cramer's rule problems on tonight's homework using the calculator exclusively. On the previous page, you can bounce back and forth between calculator and non-calculator, but on these particular questions with the Cramer's rule applied, please just use your calculator. I'm going to go ahead and speak briefly to how Cramer's rule unfolds. It is a 2 by 2 matrix divided by, and determinant that is, divided by another matrix, C they call it, and then similarly the same goes for, well, the second little expression. So this is technically the x coordinate of your answer, and this is the y coordinate of your answer. Now, as it turns out, the system of equations will always start up in this particular setup, and if it isn't already, you should set it up such that it is in standard form. AX plus BY equals M, FX plus GY equals N, and ABFG will be the quote-unquote coefficient matrix, and it's based upon, well, A, B, F, G, the coefficients of the system. M and N are quote-unquote the answers, of which you'll replace for the X determinant matrix the first column, and the Y determinant matrix the second column. The denominator, as you'll see here in a moment, will be the coefficient matrix, hence the letter C, or capital C, for that matrix, which stems from, again, what we said back here on this 2x2. Let's jump in and just try to make sense out of things. So here's your system, like I said, 5, -10, 10, 25. Now that is matrix C. As you can see down below, there's your denominator determinant, which we'll calculate, or let maybe the worksheet speaks for itself. Here's your 2x2, and we'll find that determinant. Do the same thing for Y. There's your C matrix and determinant respectively. And it's an easy 2x2 determinant you could calculate actually without a calculator. They show it down below for you as well. It ends up being 225 for both denominators. This first matrix numerator, notice that 8, -2 stems from right here, the right side of the equation, replacing the M and N, or it is M and N, but it's replacing, excuse me, the A and the F, technically, that we were seeing at the beginning of the setup. So anyways, 8, -2 replaces the first column, while B and G are the same that we saw in the beginning, -10, 25. Similarly, you can see that, well, with the numerator of the Y coefficient, or Y variable matrix and determinant, we've got 5, 10. Where did 5, 10 come from? Well, 5, 10 come from the original problem. That represents A and F, essentially. And that says it up above as well. Where does M and N come from? Well, M and N, yet again, are a representation of these numbers, 8, -2, from the right side of the original system. All right, it looks pretty daunting, but again, we'll be able to use your calculator on these, and I think it'll be pretty straightforward. If you multiply 8 times 25, there's your determinant, minus -2 times -10. There's the full kind of analysis. To then find that determinant, you end up with 180 in the numerator, and then, of course, over 225 in the denominator. Do the math, and this simplifies down to be 4/5. The second fraction ends up being, if you do the math, 5 times -2 minus 10 times 8. That number ends up being -90. And again, the denominator we said was 225, which then reduces to -2/5. The final solution is 4/5 over -2/5. Now this does take quite a while to type into the graphing calculator. So what I'm going to do here is I'm going to take a moment and actually use the OneNote matrix option. I'll do a quick little copy and paste here for you, and we'll go ahead and do the analysis separately. So let's take a look. If you do the analysis separately, I'm going to go ahead and do a copy and paste like I said. So I'm going to type in and do determinants kind of separately. It will be, I think, fairly nice to see it in this particular manner. Wherein if I, again, go to Insert, Equation, I'll do Structures, I'll use my bracket tool, and I'm going to choose, instead of square brackets, I'm going to choose this right here, vertical bars. This will allow me to actually use the determinant appropriately. So let's enter in 5, -10, hit enter, 10, 25. And then that alone, if you can see here, it's going to yield just on its own. If I hit, after highlighting it, hit the math button, and then select the action of evaluate, it's going to do the determinant for me. And it'll even show the steps, showing the diagonal rule particularly. You could do this with every single matrix, of course, and then you'll do the division from there. I certainly recommend you try that. The answer, of course, being 225. Okay, I certainly recommend you do that, not just for this matrix, but also for the other two matrices. And like I said earlier, not only are you going to be finding 3 determinants, you're also then going to be dividing those determinants as such. So 180 over 225, which is 4/5, and -90 over 225, which is -2/5.